The next topic we are going to discuss is vectors and matrices. So vectors and matrices are used to store sets of values, all of which are the same type. A matrix can be visualized as a table of values. The dimensions of a matrix are R by C, where R is the number of rows and C is the number of columns. A vector can either be a row vector or a column vector. If a vector has n elements, a row vector would have the dimensions 1 by n and a column vector would have the dimensions of n by 1. Scalar has the dimensions 1 by 1. Therefore, vectors and scalars are actually just special cases of matrices. As we all know, MATLAB is written to work with matrices. The name MATLAB is the short for matrix laboratory. So it is very easy to create vector and matrix variables, and there are many operations and functions that can be used on vectors and matrices. So these operations are referred to as array operations. Now first is how to create row vector. So there are several ways to create row vector variables. The most direct way is to put the values that you want in the vector in square brackets and separate by either space or commas. For example, I'm just creating a variable v equals to 1 space 2 space 3 space 4. Or you can create a row vector as v equals to, and in square bracket 1 comma 2 comma 3 comma 4. So this is how you can create a row vector. You can also use a colon operator or line space functions. So colon operator can be used to iterate throughout these values. Like I'm using vec equals to 1 colon 5. So this results in all of the integers from 1 to 5. You must know that in this case the brackets are not necessary to define the vectors. With the colon operator, a step value can also be specified by using another colon in the form as I'm creating a variable r equals to 1 to 9. I'm just going to create a value from 1 to 9 with the step size of 2. So this will create a vector with all integers from 1 to 9 in steps of 2. You can also use a linspace function that creates a linearly spaced vectors. Like ls equals to linspace (3, 15, 5). So this will create a vector with 5 values linearly spaced between 3 and 15, including 3 and 5. Similarly, there is a log space function that creates a logarithmically spaced vectors. Like log space from 1, 5, 5. So this will create a logarithmically spaced vectors. Vector variables can also be created using existing variables. For example, I'm just creating a new vector as v space vec. So putting two vectors together like this to create a new one is called concatenating the vectors. Now, if you want to select a particular element, just write it as new vec 5. So the fifth element in the vector new vec is 1. So this expression will be pronounced as new vec sub 5, where sub is short for subscript. A subset of vector, which would be a vector itself, can also be obtained using the colon operator, like v equals to new vec 4 colon 6. So the following statement would get the 4th through 6th elements of the vector new vec and store the result in a vector variable b. So if you want to get some specific elements of the vector like new vec, one, 10, 5. Sorry, I have exceeded the vector dimensions. It will be 1. I'm using 7, 5. So this is an index vector. It specifies the indices in the original vector that are being referenced. The value stored in a vector element can be changed by specifying the index or subscript. For example, to change the second element from the preceding vector b to now store the value 11 instead of 2, you can write b 2 equals to 11. So this will stores the value 11 instead of the value 1. By referring to an index that does not yet exist, a vector can also be extended. For example, the following creates a vector that has 3 elements as rv equals to 3 space 55 space 11. So this will create a vector with the values 2. Now I have to add another value, or we can say as a 4th element. So I can write it as this. So this is how you can create various column vectors. Sorry, it's row vectors. Now in our next lecture we will discuss how to create a column vector. So this is all for today. Thanks.